All right, now let's get to that curve sketching idea. So sometimes on the AP test, you will be asked to sketch a little piece of a curve. They'll typically give you an axis like this in order to sketch this. So what are we given the graph of in number 5? We're given the graph of f prime, okay? So I'm going to say that is f prime that I'm looking at. So here's what they give us. Suppose that f of 1 equals 0. And the plane provided, draw a sketch that shows the general shape. Okay, so the only actual coordinate we know is that as a point 1, 0. Now we want to draw the general shape, just not in the whole interval, but just 0 to 2. Just 0 to 2. Okay, so if they give you a point and I'm asked to graph the function f, then let's go ahead and put the point they gave me on there. Okay, so we know f of 1 equals 0. Okay, so now let's go back to what we are looking at. So we're only looking at the graph of f prime only from the interval from 0 to 2. So I'm going to kind of shade in the interval that we're looking at. Okay. Do you see how I've got like 2 different pieces to this graph, right? I kind of have from 0 to 1, this graph is doing the same thing, right? And then from 1 to 2, this graph is doing the same thing. Yes? Okay. Again, some of you are going to be better at this than others. What I'm going to do is I'm just going to try to get this nice and organized for you guys. So you see how on 0 to 1, what is f prime doing? And we're looking for 2 things. Is f prime positive or negative? F prime is negative. That means it's below the x-axis. And what else is it doing? It's increasing. Okay. So if f prime is negative and increasing, what does that mean f is doing? What is f prime being negative? Look back at your function analysis chart. F is not concave down. So what does f prime negative mean? It means f is decreasing. And what does f prime increasing mean? F is concave up. Do y'all see that? So from 0 to 1, when we draw the graph of f, we're going to draw a piece of the graph that is decreasing and concave up. I don't care about any points on it. I just care that it's going to hit the point 1, 0, and that it's decreasing and concave up. And notice it's on the open interval from 0 to 2. So right in there, draw your little piece of elbow macaroni, right? That is decreasing and concave up. So it's going to look like this. Do y'all agree? That little piece right there is decreasing and concave up. Any questions? Try now adding in the piece from 1 to 2. Okay, have y'all drawn your piece in? Not yet, okay. It should look like? It kind of looks cubic, right, in that one little area. Yeah, okay. Any questions on that? Okay, I'm going to do 2 more with you guided, and then I'm going to kind of let you guys just work the rest of the period, okay? All right, so let's do the next 2 together, and then we'll just work time. Okay, this time, this is another classic type of problem. Instead of giving you a graph, they're giving you numerical information about f, f prime, f double prime, and we're asked to sketch the graph of f, okay, that has all of those things happening with it. So it's important that we're able to read this type of graph. Okay, we're trying to sketch the graph of f. So what information do we know about f? Well, we know a few points, right? If they give us actual points and they're asking to sketch the graph, that's where I would start to make sure we got the right points on there. So we're going to go ahead and put those points. 0, -1, 1, 0, 2, 2, and 3, 0. Okay. Now, between each of those points, we're just going to piece together those little pieces of elbow macaroni together. We just got to get the right shape. So between 0 and 1, f prime is positive and f double prime is negative. So what does that mean about f? If you want to annotate that, do so. What does f prime positive mean about f? F is increasing. What does f double prime negative mean about f? Concave down. So the piece from 0 to 1, you want to draw that piece increasing, but concave down. So this little piece right here. Questions on that little guy? Finish the graph.
Would it end up looking like a piecewise?
Yes, it will look it'll look piecewise. It won't look like a function you're familiar with. Draw the other three pieces. So this is what we should have gotten. You should have had the next one be increasing and concave up. So it looks like that. Right? Increasing concave up. The next one is decreasing and concave down. There's the lovely shark fin. Then the last one should be decreasing and concave up. Now, Luke, I like how you put this right here because you were like, they didn't give us the point. They're not specific. Actually, it does say it's continuous on the interval from 0 to 4 with an open endpoint at 4. So yes, that would actually be what you would want to see is a little open bracket right there. Yep, good. All right, last one that I just want to make sure that we're all good together. Do number 7. There's no justification or anything. Just give me how many points of inflection does. I just want you to read carefully and also figure out looking for those points of inflection. So I've got the answer 3, 4, and 5. The correct answer is 3. The correct answer is 3. Okay, so on the closed interval, so I'm going to mark them. So you see how this is concave up, right? And then right in here, we start going concave down. So there's one right there. You'll see that? They kind of have a concave up, and then it starts changing concave down. All right, this is concave down, and then right in here, you can see I'm changing to concave up, right? All right, and then we're concave up, concave up, concave up. We've got a nice little up like a cup, like a little smile, and then we start frowning. So we've got 3 points of inflection. Are we all good with the 3 points of inflection?
I wanted to come back to this problem number 7 and look at this problem in a different way as well. So the original problem was looking at the graph of f and finding how many points of inflection it has on the interval, but that's a pretty simple question. And so I wanted to look at it in a different way, and that is, what if I changed the question from y being f, but to y equals f prime? So let's consider that this is the graph of f prime, and I'm asking the same question: how many points of inflection does the graph of f have? Okay, so if I had the graph of f and points of inflection of f, that's pretty easy, right? We just look at where it changes concavity. However, if I'm given the graph of f prime and asked how many points of inflection, that takes a little bit more work or analysis that we have to do. So that's why I wanted to think about it this way as well. All right, so if I'm looking for points of inflection of f given f prime, so just recall our chart for f, f prime, f double prime. So I'm just going to redraw this. We went over this before. But what I'm looking for is I'm looking for a point of inflection on f. So that means when f is changing concavity. So you're looking for a change between concave up and concave down, or vice versa. If I'm given the graph of f prime, what you're looking for is the information that f prime is changing from increasing to decreasing, or vice versa. So if this is the graph of f prime, we're looking for basically where you have maxes and mins. All right, so we've got changing from decreasing to increasing here. So this would be a point of inflection on f, again, because f prime changes from decreasing to increasing there. And then we would also have a point of inflection here on f, because f prime is changing from increasing to decreasing. Here we have the f prime is equal to 0, but it's not changing from increasing to decreasing there. So that's not going to be a point of inflection on f if this was the graph of f prime. All right, so I just thought this was a valuable discussion to have, to just make sure if you're given a different information, how to find points of inflection. So if this was the graph of f prime, we'd have 2 points of inflection between 2 and 7.